So our next topic is the average rate of change. And we're going to start with an example. So the following table represents the growth of a bacteria population over a 10-hour period. I've also included the graph showing the number of bacteria versus the time in hours. Part A. Determine the average rate of change in the number of bacteria over the time interval 2 to 4. So if we want to find the average rate of change, we're trying to find the change in the number of bacteria at 2 and at 4 and compare it to the time. And if you think about what that is, so here is the change in the number of bacteria, and here is the change in time. And what essentially we're looking for is the slope of a secant. So what we see below is that the average rate of change for any function over an interval is the slope of a secant line passing through 2 points. So the average rate of change is basically delta y over delta x. So for our first example, if we want to find the average rate of change, or what I'm going to short form as the AROC, we're going to get the change in y, which in this case is the change in the number of bacteria, over the change in x, the time in hours. And the 2 points we're focused on are 2 and 4, and there are the corresponding y values. So we have delta y over delta x, which in this example is 1481 minus 1122 divided by 4 minus 2. Using your calculator, you'll see you get 179.5 for the slope of your secant. We have units for average rates of change. So since it's the change in y over the change in x, our y value was the bacteria count, and our x was time in hours. So the average rate of change between 2 and 4 is 179.5 bacteria per hour. Well, what does this mean? This means that the number of bacteria is increasing on average at a rate of 179.5 bacteria per hour between 2 and 4 hours. Now, while we know those 2 points, it doesn't mean that it was a consistent or going up at the same rate throughout the 2 to 4 hour range. You could have done something like this, gone up, gone down, but then came back up. That's why we say on average. We don't know what happens in between, but on average, within that time frame, the rate is increasing at 179.5 bacteria per hour. It might be faster at some time within that 2 hour gap, or it might be slower. So determine a 2 hour interval in which the bacteria population grew the fastest. And from a graph, that's easy to identify. If you didn't have a graph, we'd have to calculate all these rates of change. But take a look at the 2 hour intervals. If I draw a triangle here and compare the rise over the run versus, let's say, the end here, they have the same length in terms of their run, the delta x if you like. So this is 2 hours. And this is 2 hours. You can see that this triangle is definitely the tallest amongst all these 2 hour intervals. So this one would have the largest slope or the largest rate of change. So again, the greatest change in the bacteria population will occur when the secant line is the steepest, and on the graph we see that the secant line is the steepest during the last 2 hours. You've heard this word secant line a few times. And all a secant line is a line that passes through 2 points on the graph of a relation. Example 2. A water tower holds 1,600 liters of water. It takes 2 hours for the tank in the water tower to drain completely. The volume V in liters of the water remaining in the tank at time t in minutes is shown in the table and graph. Determine the average rate of change in the volume over the interval 30 to 90. Here's 30, and here's 90. So we're looking for the average rate of change or the slope of this secant line. So our points here are 30 and 900 and 90 and 100. So the average rate of change is equal to, in this case, delta V over delta T, the rate of change in the Y values, or the rate of change in volume divided by the rate of change in time. So that's V at 90 minus V at 30. So using some function notation, over 90 minus 30. And looking at the chart, that's 100 minus 900 over 90 minus 30. And then using our calculator, we get negative 13.3, or approximately negative 13.3 liters per minute. So that's the rate of change between the 30th and 90th minutes. So therefore, the volume of water is decreasing on average at the rate of 13.3 liters per minute between 30 minutes and 90 minutes. Part B. Does the tank drain at a constant rate? And explain. So let's go back to our graph and taking a few triangles here. So let's look at this one here. So this would be the slope triangle here. And let's take one down here. Notice how the height of these triangles are changing. So they're definitely not the same slopes between points. So we can see that the water is not draining at a constant rate. If it was, it would be a straight line over this 2-hour period. And we can see that from the graph because it's a non-linear relationship. We can see that it's faster to start. The water drains out quickly, and then it starts to drain more slowly. Right, what happens if we don't have a table or a graph? So our final example. An advanced functions textbook is tossed from a cliff that is 120 meters above the water. The height of the book above the water is modeled by h of t equals negative 5t squared plus 10t plus 120, where h of t is the height in meters and t is the time in seconds. Calculate the average rate of change in height over the time interval 2 to 3. So algebraically, if we want to calculate the average rate of change for any function, it's the same formula. It is delta y over delta x, which is just f of x2 minus f of x1 over x2 minus x1. So for this example, the average rate of change is going to equal delta h, the change in height, over the change in time. And since it's between 2 and 3, it's going to be h of 3 minus h of 2 over the change in time, 3 minus 2. Using your calculator, you should get 105 minus 120 over 1, and that equals negative 15 meters per second. So therefore, the height of the book is decreasing on average at a rate of 15 meters per second between 2 seconds and 3 seconds. Describe what the average rate of change means in this situation. Well, since the rate of change compares the change in distance over the change in time, the rate of change represents the speed of the book over the interval. And here are some questions that you should try.